Okay, let's continue. For the next couple minutes, we're going to talk about some of the specific Android widgets, the things that we will actually lay out in these XML layout files. A good place to start is a text view. A text view is like a static text label, displays text, very simple, enormously useful. There are, as we start to explore these widgets, you'll see with each widget you specify the type, what sort of a widget is it, and we're going to look at 5 or 6 of them here. And with each widget there's a collection of attributes, and in some cases there can be quite a few. The common attributes, you'll usually always have a width and a height, as indicated here, view attributes, and there'll usually be many others. Here are a couple of text view widgets, and notice here in the XML, so we have an opening, a so-called XML tag. The opening tag indicates that it is a text view element. So here's the opening. Note the close. So it's an angle bracket and text view, and notice the close. The close is a slash and an angle bracket. That means that's the end of the text view element. Notice here we have attributes that go with the text view. So very common, width and height. Android : layout width equals fill parent. What does that mean? It means we're going to use a namespace defined as part of the Android development kit. That's what the Android : means. The element within that namespace, and a namespace is just a collection of artifacts that share a common naming organization. The specific element in that namespace is layout width, and the value of that element is fill parent, as you see here in quotations. Similarly, we've got Android layout height, and that's wrap content. We'll get to the difference between fill parent and wrap content in just a moment. One more important element for a text view widget is the actual text itself. In this case, as we did in the Hello World assignment, we're referring to a string for the text that's defined in the strings.xml file, and the name of the string is hello. Note right below we've got another text view widget, fill parent, wrap content. In this case, for the text attribute, we're specifying the text literally right here between the quotes. If you do this in Eclipse, this is a non-preferred way, a non-recommended way to do it. If you do this in Eclipse, you'll get a little warning. You'll get a little warning in Eclipse saying you shouldn't use a literal string. And I would prefer that you get in the habit in this class of actually putting your strings into the strings.xml file. Okay, that's text view. Now, we talked a bit about this idea of fill parent and wrap content. What does that mean? And you see those with the both the layout width and the layout height elements. Very important, pretty simple, but very important. You'll see them all over. So let's start with match parent or fill parent. Now those you can treat those as essentially the same thing. Up through Android API 8, which was quite some time ago, it was fill parent. It was changed to match parent. You can now do them interchangeably, and you will see them both in the examples and in the literature. What does it mean, fill parent or match parent? It means that the view and the text view, take our label, our static text label, it wants to be as big as its parent. So if, for example, our layout width is fill parent, the parent is this whole screen here. So the width wants to be as wide as the parent that it resides in. In this case, it can be as wide as the whole screen. Wrap content means that the view wants to be just big enough to enclose its content minus any padding. I strongly recommend, we can read this and we can understand what it means, but go ahead and try it. Try it in some XML layout files. You'll see pretty quickly these two seemingly simple attributes can have enormous consequences in the way your layout looks. But match or fill parent means that the view wants to be as big as its parent, and wrap content means that it just wants enough. It just wants as much space as is necessary. All right, moving along. Continuing with text components, we'll look at edit text. Edit text, and the class here is android.widget.editText. Edit text is a subclass or a child class of text view. It's very similar to text view with one very, very important distinction. With text view, just a static text. You can change it programmatically, but the user cannot change it. Not change it directly anyway. Here, this is an editable text box, an editable text control. So we see here. Here's how we would specify this in the XML layout file. So we've got edit text, opening, closing with the slash and the angle bracket. Here's our width and height. Match parent wrap content. So the width means I'm going to take as much. I want to match the parent. So if I'm in an activity on an activity screen, I'd like to have the whole width available. Height wrap content, just give me as much as I need. Notice in this case, if I had asked to match parent for the layout height, my control in height would take up the whole screen. Not very useful. No, imagine what a user would think of that, of a editable text box where it took up the whole screen on the mobile device. Here, the text, the same situation as before. You can actually have literal text right in between the quotes, or you can have @ string / and a reference to some string. The text that you put here is the initial text that will come up in your. It's sort of the default text that'll come up in the edit box, and the user can just reach over, touch over, and change the text to whatever they want. So that's an edit text control. All right, let's keep moving. Here is another very important control. Simple, widely used, very important. A button control. So android.widget.button is the class. This is your basic button control. It works how you expect it to work. The common thing in user interfaces and Windows computers and Apple computers and Linux and Unix computers, mobile devices, pads, tablets, all the major vendors, just a button. The label may be text or an image, and something very important, and it'll be the subject of our next lesson. No functionality unless the button is associated with a listener. What does that mean? Unless I associate the button with what's referred to as a listener, nothing will happen. You can click the button and you'll see, you get a little graphic indication that there's been a user action to click the button or to touch the button. But unless we tie that event to a listener, your Android app will not take any action. Listeners are simple. Here's a little piece of Java code, and here is a simple listener. Now don't worry too much about this code at the moment. But next week, this will be one of the main things we do. And when we do that, I'll show you a full example with the associated XML text to add one of these buttons into your XML layout file. And then what we're essentially doing with the listener, we're wiring the button into our application. Note with the buttons, you can have a text label, you can also have an image label, and with an image label, our images are stored in the drawable resources/drawable folder, and again, don't worry too much about that for the moment. It's something we'll get to in subsequent weeks. But buttons, yeah, you'll learn how to put buttons into your layout files, and how to wire them up with listeners. That'll be next week's activity. A variant on that theme of button is a toggle button, android.widget.toggle button. It's just a special kind of a button, and it's a two-state. It's a toggle. It doesn't have to be on or off. It often is on or off, but it need not exclusively be on or off. What you get is this graphic indication, this little green highlighting that the button has been pressed or not, or it's in one state or another. Here is the XML for inserting one of these, for laying one of these things out. Android layout width equals wrap content, same as before. Height is wrap content, so we want to take just as much space as we need. And the text on, this is again, text on is an attribute, and that's where you get this little graphical highlighting. Again, you can specify the text right here literally, or you can do @string and reference to a text. So and you can also wire these up with an event handler, or a listener, as we discussed with button. So basically a button with a little bit more, some focused functionality. Checkbox, not really a button, sort of a selectable button. So you use checkbox with a list of items. Now with a checkbox you can have 1 to n items. The user can select all or none, or some, or one. It's you can select multiple items, and each checkbox can have its own text attributes. So here, and this hopefully is starting to look pretty familiar. We've got checkbox, opening, closing, layout width, wrap content, layout height, wrap content. So just give me as much space as I need. And here, there's the text. That's its first one. Check the box. And the next two, same approach. And notice here, automatically, it's not something you have to do. When the button is checked, or when the user has reached over and touched the checkbox, you get the check indication. And to sort of think about it, a reasonable question is, well, can I tell that it's in that state? And the answer is certainly. Certainly you can tell that it's in that state. You can programmatically see if it is checked or not. Okay, moving right along, here's another kind of control, a popular sort of control. It's called a spinner. A spinner, it's like a checkbox in that it's used to present you with a list of choices, but it's commonly used with a known list, and it's used to sort of limit the number of things, your number of choices. For example, you might use something like this if you wanted the user to specify a state. Be kind of a big spinner, but you could do it like that. Colors, as is shown here in the example. Days of the week. You would use a spinner where you have a finite number of choice. States is probably a bit of an extreme example, that you get 50 choices. It'd be doable, but usually you see it with fewer than that. It's called a spinner because when you touch up on it, when you swipe up on it, and I'm sure you've all seen this, you swipe up on it, it gives the impression that it's spinning as the choices go by. You can only have one of the choices selected, and so that's why it's really useful where you've got a set and you want the user to select something out of this set. A little bit of a twist here. Let's look at the XML declaration. So here, as with all of the others, you've got an opening and a closing. Layout width, layout height, match parent, wrap content. And in this case, you can see it really makes sense to do it that way. We want it wide and as high as it needs to be. Here's a bit of a variation. Notice here, Android entries equals @array / colors. So your choices can actually be specified in an array, and you could do it programmatically with an array, a regular Java array. But in the Android toolkit, there is also a way to specify this XML layout, this XML array as an XML file. So this week we're just sort of doing an overview of different kinds of components. We'll actually look at this later in the semester, where we use some spinners and we create these Android array files. The other thing you hear, Android prompt, that's, in this case, the prompt is spinner control. So @string spin prompt, and this is again this idea of you've specified the literal value of the string in this strings.xml file. So that, we'll get into XML basics in a moment in our next video, but that's an overview of really just a handful of some of the widgets available for your use in the Android UI. There's many more. The good news is once you sort of get your head around a few of them, it's not very difficult to learn how to use others. They all have sort of this same approach with an entry in a XML file for initial layout, and then you specify the attributes using this XML approach. So we'll continue with XML, a little XML tutorial in our next video. So see you soon.